Hello students, my name is Shashank Shekhar and today is the fifth lecture of the chapter Amines. So far, we have covered the physical and chemical properties. Okay, today we will see some of the reactions. So we have covered half of this physical and chemical properties. We have not seen all the reaction. Only we have seen the basicity. Okay, so we will see the chemical reaction and then we will move to the identification part. So how you can use chemical reactions to identify primary, secondary, and tertiary. So basically, what I am telling is that we have several methods for laboratory for distinguishing various functional groups. So for example, we have this Lucas test for distinguishing primary, secondary, and tertiary alcohol. Similarly, for amines, we have a different test which is called as Hinsberg test that is used for the identification of primary, secondary, and tertiary amine. So we'll look at that, and I think that is very important from the exam point of view. The remaining topic that we will cover in the next lecture is diazonium salt. So we'll look at it in the next lecture. So for today, let us look at the chemical reaction and the laboratory method that is used for the identification of primary, secondary, and tertiary amines. Okay, so let us look at the topics that will be covered today. First, we will start with the chemical reaction, and the first reaction would be alkylation. Then we'll look at acylation, carbylamine test, and this is also a test that can be used for the identification of amine, that whether amine is present in a reaction in a mixture or not. Then we will see the reaction with nitrous acid and aryl sulfonyl acid, and after that we will move to the reactions of aryl amines. So these are mainly the reaction of alkyl amines, although they are given by the aryl amines also, but majorly they are done with this alkyl amine. After that, we will move to specific reactions that are being specific to aryl amines, and the first one would be your electrophilic aromatic substitution, in which we will study bromination, nitration, and sulfonation. Okay, so let us start our today's class. First, let us start with this alkylation. So how do we do the alkylation? So we have seen a similar alkylation process that was termed as William ether synthesis. Okay, so what do? We take a ether, deprotonate it with the help of a base, and then treat it with a haloalkane, that is bromohalide here, and then we get this compound which is ether. Similarly, if we carry out this reaction, if we treat rather than using this RO minus, if we use NH3 and an alkyl halide, then it would result in a mixture of primary, secondary, and tertiary amine. We have seen this reaction when we are using this reaction for the preparation of tertiary amines. Now you would ask, what is the alkylation process here? So of course, the first product that is formed, that is your primary amine, is simply the preparation of your amine. Now when this hydrogen is further deprotonated and it is now substituted with the second group, this group, so it is kind of alkylation of this chain to give this. Again, alkylation of this gave this. So what I am saying is that first we get this product, further on alkylation of this we get this thing, and alkylation of the second one give the tertiary. Okay, now the main problem is that the product are more substituted, generally more nucleophilic than the starting amine, resulting in over alkylation. So the problem with this reaction, as we have discussed earlier also, so it gives a mixture of amines rather than a specific amine. Anyways, we have done this. This is the alkylation method. Next is the acylation. What is acylation? So acylation, by acylation we mean that we are acylating something, which means that we are adding CH3CO group. How do we do this? So for that, we treat our amine, whether it is primary, secondary, or tertiary, that doesn't matter. We treat our amine with a acyl chloride. So how do we prepare acyl chloride? That is the first question. So this is the substrate, no problem. But how do we prepare the acyl chloride? So if you have attended the previous lecture, then you must have seen a reaction in which we treated our carboxylic acid with SOCl2. So if you do this reaction, which is a SNI reaction, if you do this reaction, you will get this thing, that is your acyl chloride. No problem in this one, this reaction. If you don't know the mechanism, I'm just giving you a hint here. I will not do the whole mechanism. I'm giving you a hint here. First of all, this reaction goes by SNI mechanism, and the first step would be the attack of your O on this group. So we have a SOCl2. SOCl2 looks like this. So first of all, this lone pair will attack here. This will move up and will come back and kick out this Cl to give what it will give. It will give here a sulfur. So we'll have a sulfur here with a oxygen attached, double bonded to it. Okay. Now you can do the rest of the reaction. Here we have a positive sign which will be released to release this HCl. Now you can continue the reaction if you want. You will finally get this thing, which is called as acyl chloride. Now how is it, how this reaction goes further? So what do we do is that we treat our amine with this acyl chloride. Now if you look here, this acyl chloride has a nucleophilic center here. Here we have a nucleophilic center, and the nitrogen had lone pair in it. The lone pair will attack this center. This will go here and it will kick back the Cl minus, and we'll get our ethanamide. This is called as ethanamide, N-ethyl ethanamide. So N-ethyl for this group and ethanamide because this is the amide. Next, again we can take secondary amine also. So secondary amine will also attack. We'll kick out the Cl minus, so it will attack here. This lone pair will go here. It will come back. It will kick back this Cl out, which will result again in a amide. But this is a N-diethyl ethanamide. Now, what we can do, in the place of acyl chloride, we can also use an anhydride. So what do? We take a amine, primary amine, then we treat it with the anhydride. Now again this lone pair will come and attack here. This will go up, come down and kick out this carboxylic group, okay, and will make acetic acid out of it, and N-phenyl ethanamide. So what are the reactions that we have seen? So basically, if you take primary and secondary amine and treat it with acyl chloride, then it would give us the amide, substituted amide, N-substituted amide I would say. And if we treat it with the anhydride, then also it will give a N-substituted amide. Now what we can do, we can take another reaction where we can use say the benzoyl chloride in place of the acyl chloride and our amine. This will give the same reaction, no problem. Only we have introduced a substrate that is different from this. So we have used C6H5CaCl in place of this CH3COCl. Now, if this reaction is carried out in the presence of a strong base like pyridine, which remove HCl, so to form which remove HCl, so form and shift the equilibrium to the right hand side. So what it is written is that, so in every reaction you will see that we are getting a HCl at the last. So what do? We carry out this reaction in the presence of a base like pyridine. So if we use such base, that base will just remove HCl by reacting with it. It will form this thing. So pyridine looks like this. What it has taken? Pyridine. Pyridine, it is this. So this N will take the hydrogen and carry a positive charge, and this will make a salt like this upon reaction of HCl with pyridine. Now what will how it will affect the reaction? So we know by the Lee-Chatterjee principle that if we remove the base the product concentration, or if we alter the equilibrium, I would say, then the reaction proceeds in such a way that the effect of change can be neutralized. So if we remove the HCl, then we remove the product. So to facilitate the reaction, or you can say to maintain the equilibrium again, or to bring back the equilibrium again, the reaction will proceed further in the forward direction to again produce that reduced HCl. Did you get it? Okay. So that is why we use this pyridine for acylation process, so that the reaction can be facilitated in the forward direction. Now next, let us move to a very important reaction that is termed as carbyl-amine reaction, and this reaction is very popular in the laboratories. Means it is often used in the laboratory for the identification of amines. So let us see this reaction. So this is your carbyl-amine reaction. This is your carbyl-amine reaction. So how do we carry out this reaction? So in this reaction, we can take both aliphatic and aromatic amine. Okay, so we can take both of them. We can take aliphatic or aromatic amine. Now, what will happen? We will treat this aliphatic or aromatic amine with CHCl3 and base. Now, the important thing in this reaction is that you should be aware about the coefficient, because that can be sometimes asked in the exam with the help of a mole concept question, and you will get confused. So you should be aware about the side product as well. Now this reaction is only given by primary amine. Okay, this reaction is only given by primary amine. So it can be used as a distinguishing test for primary and other amines. Okay, so if you have a primary amine, then only it will give this reaction. Now, how does this reaction go? So if we treat our amine, that is our primary amine, with chloroform and in the presence of a base and heat it, then you will get something which is RNC, and it is called as cyanide. Okay, cyanide. Okay, isocyanide. Why iso? So each time this nitrogen gets attached. So we have also an example called cyanido, which looks like this. Now if we attach it with this N side, then it is called isocyanide. Similarly, CN, if the CN is present, then it is termed as cyano. If it is attached from the nitrogen side, then it is called as isocyano or isocyanides. Now it is also called as carbyl amines. Okay, so that is why this reaction is called carbyl amine reaction, because we get a carbyl amine here. Now this the physical state or the physical attribute that is used for the identification that the reaction is being carried out is that upon the formation of this carbyl amine, we get a very foul smell sensation. So we get a sensation of very foul smell. Foul means bad smell, I would say. That is often referred to as rotten egg. No, not rotten egg, foul smell. So foul rotten egg is associated with H2S. Okay, yeah, anyways. So if you look at the mechanism of the reaction, this reaction is quite complex because it involves the formation of your nitrine. So what is nitrine? Sorry, carbene. What is carbene? So carbene is something which is having the appropriate number of electrons it should have. Okay, means we have 3 electrons involved in this, 3 to 6. But we have what we have done is that we have removed one more Cl and we got 4 electrons. Okay, 4 to 6 electrons. So carbene is a species that is having all electron paired, but it has only 6 electrons. Now how this reaction will go? So what do we do? First of all, let us look at the mechanism here. So we have CHCl3. A similar mechanism is also followed for means the substrate that will be formed. The carbene formation method is same as the Remer-Timmer. We use the same CHCl3 and KOH. So first this KOH will remove the H and we will get CCl3 minus. Further, this Cl will be removed automatically to give this. This is called as carbene. What it is called? It is called as carbene. Now next what will happen, we have an electron deficient compound, which is this electron deficient, and we have a nucleophile RNH2. So this RNH2 will attack CCl. So it will donate its electron to this CCl. This will result in the formation of CCl minus. Okay, clear? So it will form CCl minus, and nitrogen will form positive, because now it was RNH2 plus, RNH2. Okay, no problem till now. Now next what will happen, this extra bond will come here. Okay, and you will get R N H. This Cl will be kicked out. You will have one Cl only with a negative charge. Next what will happen, so we have this species which is R N H and C Cl minus. Now again this will come here and this will be kicked out. This will result in the formation of your RNC, that is your isocyanide. So this is the overall mechanism for the carbyl-amine reaction. So first what we do, we treat our base with the chloroform to get rid of H. Again this chlorine leaves by itself and forms a dichlorocarbene. Further, this nitrogen attacks the trichlorocarbene and forms this. And again now H minus picks up one hydrogen, and again the next H leaves and we get the carbene. Now throughout the reaction we get KCl 3 times, here, here and here. Therefore we have 3 KCl. NH2O 1, 2 and 3 times. So again 3H2. And KOH is used, 1 here, OH minus 1 here, then OH minus 1 here and OH minus 1 here 3 times. So we have 3 KOH and CHCl3 1 time. So 1 CHCl3. So this is the overall carbyl-amine reaction. So this is so if we summarize this thing without going through the mechanism, so it is basically a reaction of amine with chloroform in the presence of base to give isocyanide, which is identified by its foul smell, and this method hence can be used for identification of primary amine. Now if I ask you why primary amine only, why not any other amine? So if you see here, this reaction involves the proton abstraction 2 times, here and here, and both the proton are deprotonated from the nitrogen only. So if it does not contain enough hydrogen, then this reaction will not be carried out, and 2 hydrogens are present only primary amine. So this is the reaction. Now next we will move to the distinguishing test. After this, the nitrous, first of all we will see the nitrous acid test, and then we will see the distinguishing test. So this is the reaction with nitrous acid. So what happens in this reaction? We treat our amine, whether it is a primary amine or say secondary amine, tertiary amine, aromatic amine. This results in the formation of something which is called diazonium chloride. Similarly, if we take the aromatic also system also, we will still get the aromatic diazonium chloride. Now the difference between the reaction between primary and aromatic is that the primary amine reacts with NaNO2 and HCl at any temperature, while in case of aniline we have to provide a temperature that is near to 273 to 278. Now the reaction with aromatic amine is very important, and primary amine is also very important. But if you talk about the aromatic amine, you will get the quick application now, that it is used for the preparation of multiple types of aromatic system, or you can say functional group attached aromatic system. But the problem with this reaction is you have to carry out a very low temperature. So it is also sometimes referred to as 0 to 5 degrees Celsius. So do not get confused. Only the meter scale has been changed. So we treat our aromatic amine, that is aniline, with your NaNO2 and HCl at 0 to 5 degrees Celsius. Then we get benzene diazonium chloride. Now what this is, the use of aromatic amine is quite common. But what is the use of aliphatic amine? What happens if we use aliphatic amine? So this reaction, this aliphatic amine reaction, is often used for the quantitative analysis of nitrogen. Okay, for quantitative analysis of your amino acids and proteins. Why? Because you can see in the reaction that nitrogen gas is released as the last. Now this nitrogen gas can be quantitatively means calculated or estimated, and the quantitative evolution of the nitrogen gas can be used to say estimate the number of amino acids that are being present here. The amino acid, if you talk about amino acid, it is a structure which looks like this. It has both amine and the carboxylic group. So this amine group that is present, this can be used for the diazotization reaction, and the nitrogen that is released, it can be estimated to just get an idea of the amino acid that we are looking upon. But the problem with this, but what is the problem with this reaction? Means, I would not say problem, I would say how does this reaction go? So it goes same as the diazonium chloride. First of all, it forms the diazonium chloride, but it is not stable at all. So as soon as it forms, it quickly just break down into alcohol, nitrogen and HCl in the presence of water. Now secondary and tertiary amine does not give this reaction. This is very important point to remember, that the primary aliphatic amine and the aromatic amine only give the reaction with nitrous acid. The secondary and tertiary does not give any such reaction. Now next we'll see a reaction that is used for say this distinguishing of primary, secondary, tertiary amine, and it's called Hensberg reaction. So in this reaction, what do we see? So in this reaction, what happens is that we treat our amine with aryl sulfonyl chloride. So in this reaction, what do we do? This reaction is also called as Hensberg reagent. This reagent is also termed as Hensberg reagent. So in this reaction, we treat our primary and secondary amine with this Hensberg reagent to form sulfonamides. Now this reaction is very important because it is used as a distinguishing factor, because it reacts differently with different degree of amines. In fact, it does not react with tertiary amine. So you will see the reaction. So first of all, let us treat with the primary amine. So if we treat this with the primary amine, this quickly react with this. The hydrogen attached to the nitrogen sulfamide is strongly acidic due to presence of strong electron withdrawing group, and it is soluble in alkali. So what do we do? The hydrogen attached to nitrogen, means this hydrogen is attached to nitrogen in sulfonamide, sulfonamide is strongly acidic. So this hydrogen is strongly acidic, and due to the presence of a strong electron withdrawing group, sulfonyl, it is this one, it is soluble in alkali. Okay, it is soluble in alkali. So what does it mean? So first of all, let us look at the reaction here. How does the reaction go? So we have our amine. Okay, it has lone pair. It will attack on this sulfonyl center, and this lone pair will go up, come down and kick out this Cl to give HCl and your N-ethyl benzene sulfonamide. Now since this hydrogen that is present here is very acidic in nature, so if you dissolve in an alkali solution, means that is basic in nature, then it will deprotonate the H and it will be solvated in that solvent. So this is the one point. So if you treat it with the primary amine. Now on the other hand, if you treat it with the secondary amine, then it will give the reaction, no problem. But since it has no hydrogen that is acidic in nature, therefore it is not soluble in alkali solution, and hence it can be identified as secondary amine. So if you see here, it has only one hydrogen, which is now along with this HCl. So therefore there is no hydrogen in the end, and we have no acidic hydrogen that can be used for solvation in the alkali solution. in all this reaction, we are the product that we are getting is called as di N and diethyl, because we have two diethyl here, benzene sulfonamide. Now next, let us see what happens if you treat it with the tertiary amine. So if you treat it with the tertiary amine, it does not give a reaction, and it is different for primary, secondary and tertiary amine, since we can see that it is different for primary, secondary and tertiary amine. So it can use for the preparation of mixture of this amines. However, this days benzene sulfonyl chloride is replaced by para-toluene sulfonic acid, sulfonyl chloride. So if we just write it as this, this is called as para-toluene sulfonyl chloride. So nowadays this thing is used in place of the benzene sulfonyl chloride. Okay. Now tertiary amine does not give any reaction. So whether it be treated with the aryl sulfonyl chloride, it does not give any reaction. Now if you just try to summarize all these three reactivities. So first of all, if you treat your amine with aryl sulfonyl chloride, and if the amine is primary, then the product form will be soluble in alkali, while the other secondary one, if it is secondary amine, then it will not be solvable in your alkali solution. Third, if we have a tertiary one, then we do not see a reaction also. So this is the reaction with aryl sulfonyl chloride. Now let us look at some of the electrophilic aromatic substitution reaction. So first one is aniline. So what happens in aniline? So we treat our aniline with bromine. We simply treat our aniline with bromine. What will happen? So you would suggest that the bromine will be brominating this benzene at ortho and para position. But you see, the reaction is happening, and ortho and para substitute product are formed. But you can see that a tribromo substitute product is formed. Tribromo substituted means all three positions are being substituted. All three hydrogens have been removed and being replaced by the bromine. What is the reason behind it? Think about it. What can be the reason behind it? So the reason behind it is that if you have seen in the previous lecture, you must have seen that this NH2 is an electron donating group. Now, since it is an electron donating group, it has a capability to donate electron to the benzene ring. What does it do? It increases the electron density on the benzene, and hence it becomes more susceptible to this electrophilic aromatic substitution. And once each of this bromine is removed, we get a 2,4,6 tribromoaniline and plus 3HBr for each of the bromine. Now I would ask you, what can we do so as to say, suppose we are doing the reaction and we want only one position, ortho or whether para, to be substituted rather than all to be substituted, because due to the higher reactivity of the aniline, all of the three positions are substituted. So what can we do? So what they have done cleverly is that they have just replaced one hydrogen with a acyl group. Okay, so it is a very clever reaction. So in this reaction, what do? They treat their NH2 with by acetic anhydride, and this results in acetylation. So it is saying that you have your aniline, you have a benzene, you have NH2, and you have an anhydride, which looks like this. Now this lone pair attack here and will kick out this thing. We'll get this thing, which is NHCO CH3, which is this. Now we are using base here. Why are you using base here? Because this base can deprotonate this thing. So if you will use pyridine here, it will deprotonate it and form NH minus, which will further react on your acid anhydride and will give your say substituted carbonyl compound. Of course, next what will happen, if we treat this substrate with bromine or we brominate it, then you will see that there is a drastic change in the product. Only the para product is formed. Only the para product is formed. And if you further hydrolyze this group will be hydrolyzed to your amine. Okay, clear? Now, what is special about this reaction? The special about this reaction is the protecting group that we are using. What does this protecting group does, first of all? So this is the protecting group. Yeah. So you have a lone pair of nitrogen. This is being donated here in a fashion, not fully, but it is partially delocalized over the carbonyl center. Due to this, the tendency of lone pair to go in the ring has been reduced, and hence, since it is reduced, the chance of overbromination is being also reduced. So in this way, by protecting the NH group, so we have a NH here, by protecting the NH group with the help of acid anhydride, we can do the monobromination. So mono substitution can be done by NH2 group by acylation with acidic anhydride and then carrying out the reaction with bromination. So first we have just replace the H with this group. In second, we treat it with Br2. This we have done the bromination to get Br at the last position, the para position. Then we further hydrolyze it to get our required product. So this is the overall bromination reaction. Okay, clear? Now, next we will move to nitration. So next is the nitration. What is nitration? So you must have seen in the previous reaction, functional group that if we treat our any benzene substituted ring with benzene derivative with HNO3 and conc H2SO4, then you get nitro group at ortho and para position depending upon the reactivity. So if it is ortho para reacting, you will get ortho para product. If it is meta reacting, you will get meta product. Now, if you do the direct nitration of the aniline, it yields a terry oxidation product in addition to the nitro derivative. So you can see a mixture has been formed here. And in the strongly acidic medium, aniline is protonated to form the aniline ion, which is meta directing. So what it is written is that, so if we use any acid here, so it will protonate the NH2 at the same time. And due to the protonation of this NH2, we get a meta derivative also, which is present in a large amount, means almost proportional to this para product. Now, how can we control the reaction? Again, we will do the same thing. We will do the protection. So we'll take a pyridine again, which is acting as a base. It will deprotonate the NH2. Now, the NH minus will attack the acid anhydride group and will form this thing. It is protected amine. Now we do the nitration and again we do the hydrolysis to give the NH2 group. Here, what we have done, we have just benzene, we have used the nitration process to nitrate our aniline, but we have protected it first again, like our bromination. At last, we have the sulfonation. Now, what happens in sulfonation? It does not give the required product upon simple sulfonation. Why? Because this NH2 is basic in nature, and this is again, you can say obstructing the normal reaction. So therefore, first what will happen, if we treat our aniline with this H2SO4, it will form this kind of adduct. It will take one H from the H2SO4 and form NH3 plus and HSO4 minus. Now, if you want a product, what you have to do is you have to heat your product. Heat it with the sulfuric acid at 453 to 473 Kelvin. So when you do this, it produces para-sulfonic acid. Now this para-sulfonic acid will be further changed to your deuter ion. The important point to note here is that aniline does not go Friedel-Crafts reaction due to salt formation with aluminum chloride. So if you treat your aniline with AlCl3, so for Friedel-Crafts alkylation, you have to do this, then it will form the salt, that is NH2 AlCl3. So for this reason, you cannot do the Friedel-Crafts alkylation or acylation. So due to this, the nitrogen of aniline requires positive charge and hence act as a strong deactivating group for further reaction. Did you get all the reactions? So this were the electrophilic aromatic substitution. We have discussed many of them. So what we have learned today is various chemical reaction that is related to our amines. So first of all, we have started with alkylation. So if you treat our amine with alkyl halide, then it will simply kick out the halide and you will simply get an alkyl substituted or N substituted amine. Now this gives us a mixture of amine, secondary and tertiary. So you can just treat it with the base to get a product, a reactant back. Next was the acylation. So in the acylation, you take our say this CH3COCl, that is acyl chloride, which is produced by the treatment of carboxylic acid with your SOCl2. If you treat with amine, then the Cl will be kicked out and will gain a N substituted product. Next was the carbyl-amine reaction, which involves the same mechanism initially that was used for the Remer-Timmer reaction. So basically it involves the formation of a carbene, which is a sextet species which is having 6 electrons. Upon moving further, we see that upon the reaction with nitrous acid, we get a very special product that is called as diazonium salt. It can be done both with this, say our reaction with both with this aromatic and aliphatic primary amine. Okay. It can also give reaction with, it does not give reaction with secondary and tertiary one. It only gives with primary and aliphatic amine. For aliphatic amine, it is called as diazonium salt and it is very popular. But if you talk about the primary amine, then it does not stable. Okay, it is not stable and it quickly releases N2. But this instability has become a very good tool for the estimation of the amino acid. So the NO2 that is released can be estimated to estimate our amino acid, because amino acid contain both amine group and your carboxylic acid group. Then we have the carbyl-amine reaction. If you treat your amine with KOH and CHCl3, you have seen this. Okay, sorry for again repetition. Next is with the reaction of aryl sulfonyl chloride. So this aryl sulfonyl chloride is called as Hinsberg reagent and it is used for the distinguishing of this primary, secondary and tertiary amine. So if you treat it with the primary amine, then the product form is soluble in alkali because it has a hydrogen which is acidic in nature and can be deprotonated and can be dissolved in alkali. Further, if it does not have any hydrogen because it is second degree, okay, then in that case it is called as secondary and it will not form any adduct. Third, the tertiary amine does not even react with the sulfonyl chloride, aryl sulfonyl chloride. Is this clear? Now next was the electrophilic aromatic substitution. So we started with this bromination in which we said that simple bromination would result in tri-substituted product. So with this can be controlled if we use the protected amine rather than the normal amine. So for protection, we treat our amine with this acid anhydride and it turns into NHCOCH3. Then you do the bromination, you will get the para product in excess or in the major amount. Next, what we have done? Next, we have nitration. So again, if you do the nitration, what will happen? The nitration will be happening in 3 places: ortho, meta and para. And meta is present in more amount than para. Meta is present in more amount than the ortho, but it is less than the para. But why is it so? Because as we do the nitration, we have to take the sulfonating mixture. Okay. So if you use the sulfonating mixture, the H plus of that sulfonating mixture is attached to the NH of the amine and it makes it a electron withdrawing group. Further, what do we do again for better nitration? For getting a monosubstituted nitrated product which does not have mixture, we again protect it. Okay, we again protect it with the help of a protecting group, that is your CH3COOCOCH3, which is a acid anhydride. At last, we have seen the sulfonation. So this reaction is also very peculiar because as we treat it with the sulfuric acid, it does not give the sulfonated benzene. Instead, it gives us a salt. It gives us a salt, which is this. Now, if you heat it at 453 and 473 Kelvin, 452 to 473 Kelvin, it will get converted into para aniline, para sulfonyl aniline, or the further the hydrogen transfer, since this SO3H has been more stable, so it will be transferred onto the nitrogen. Okay, clear? So this is a Jupiter ion that has been formed. Now one more important point, which is that it cannot undergo Friedel-Crafts alkylation and acylation, because when we treat it with the ammonium chloride that is acting as a Lewis base, the nitrogen donates or coordinate with the ammonium and does not, you can say, proceed with the further reaction. So this was for today's class. So we have seen a lot of reactions, okay, that are related to your amines. Okay, in the next class, we will just take our one thing back, that is your diazonium chloride, which we have used earlier. We will use it again. So we will see that how this diazonium chloride that will be formed, not any other diazonium chloride, only aromatic diazonium chloride. If you take aromatic diazonium chloride, then it has a large variety of applications. So we will look at the application. Also, we will show the methods of preparation, that how can we prepare the diazonium salt. So we will look at it tomorrow. So with this, I would end my lecture. Thank you.